Since we have already discussed about this sound representation and graphic character, graphic and sound representation, then we can move to the next topic in your book, which is basically there are some minor topics to be finished. So one is that compression techniques, and
Right.
there are two things: loss compression and lossy compression. So we just want to study the theoretical part. So what is lossless compression and what is lossy compression? So when it comes to videos and especially when it comes to images. So let
Right.
me begin just by okay, just by discussing what is video and what is animation basically. So can you tell me so what is your idea about what is video and what is animation? What's the difference basically? So what is video and what is
Video
animation?
is comprised of frames of images that are played out.
Hmm?
Animation is frames of drawings.
Yeah, that's true. Yeah, this is actually frames of frame sequence of captured captured pictures. So this is a frame sequence of captured pictures. This is a frame
Right.
sequence. Yeah, frame sequence of drawings. So this picture capturing process, this is like we are not referring this as captured pictures. So we call motion pictures. Why? So we will capture picture this picture capturing process or image capturing process is done continuously. So we call motion pictures. So image capturing is you can write down this. Image capturing is
Yeah.
image capturing is a continuous process. It's a continuous process. Therefore, videos, so not just image capturing and so to the image capturing and image playback is a continuous process. Therefore, videos are called motion pictures. Motion pictures. It's moving pictures.
Yes.
This can be so. In the other hand, the animation can be frame by frame drawing or automated frame generation. So this can be frame by frame drawings. Earlier days, so I don't know whether you have looked at very earlier stage videos. So it's like they are changing slides. It's very old cinemas and all. They are changing slides. Slides means one by one they're changing. So very old
Yes.
animation based cinemas, they are changing one by one. Each and every frame should be drawn. But later, so with the this software components or software programs like Flash, so it was possible to generate the first frame and some intermediate frame or last frame, and generate the in between frames by automation. For an example, okay, if you are moving, so think that okay, this is a character, a movie character, and this is a movie character. Just assume, okay, I know this is not a movie character, but just assume that this as a movie character. And okay, so let's say first the movie character is here, and after some t time, movie character is moving to another location here. So first,
Right.
when t is 0, it's here. When t is let's say t is 10, it's here. But softwares like Flash, so it can generate the in-between frames. It can generate the in-between frame. No need to draw one by one. One by one by one by one, no need to draw. in between frames, it can auto generate. Understood?
Yes.
Okay, so I think you have seen that in TV also there's an advertisement. I can't remember the exact exact brand or the product or service, but I can remember there's one advertisement in TV. So where a kid drawing stages of butterfly, different stages of butterfly, and then change in the stages. Earlier days we used to do this in books. So in a
Yeah.
corner, yeah, corner of the page, we draw a character. Then we are changing this fast way. So for an example, this character like this, we are drawing the corner of the book. This is called book animation basically. Corner of the character, we are
Yeah.
drawing something like this. Okay. So then next page, next immediate page, we will draw the same character, same place, but with some change. With some change. Next immediate page, same character, again same place, but with some other change. Again same character, same, but with some minor change. Likewise, we draw the character, and later what we'll do, so we will turn the pages quickly. Then what will happen? You can see that the character is animating.
Yeah.
Right, this is called book animation, because basically this is called book animation anyway. So these are the concepts behind video. And so when you are playing a video, you can understand that it's a motion graphic, because when you are playing a video, if you stop in the middle, it will stop a picture. Right, if you are playing this video and I'm going to stop this in the middle, it will stop from a picture. Again, if I let it play and stop, again it will be a picture. Likewise, it is a picture sequence. Okay, then keeping this in mind, it is possible to calculate image size or video size. So I think you can remember how we have calculated image size. So assume that you are using, okay, you are using um, right, you are using 12 megapixel camera, 12 megapixel camera, and recording 1 minute video using 12 megapixel camera. Example, use 12 MP, 12 megapixel camera to record 60 seconds video. What will happen? 12 megapixel means simply, so 12 million pixels. So horizontally it's 4,000 pixels, and vertically we will assume vertically 3,000 pixels. Altogether 4 into 3 is 12, and 6 zeros means 12 million. Okay,
Yes.
right. Then one frame is 12 million pixels. Then this will record 60 seconds video with 25 FPS. What is 25 FPS?
Frames per second.
Frames per second. Yeah, 25 frames per second. Can you tell me the image or video size? Can you calculate the video size
Right.
quickly?
So it's 12 million per frame.
Yeah, 12 million per frame. 12 million per frame, and 25 such frames will be played in a second. Right? 25 such
Mm.
frames will be played in a second. Can you tell me the image size? So 12 million means how many? So 1 pixel. So if it is RGB,
30
8 bits.
million, sir.
So I couldn't tell me you the profile RGB. Think RGB 8 bit. So then
Mm.
one frame size. That is a picture size. So it is 4,000 by 3,000 pixels, and one pixel will size 24 bits, which means 3 bytes. We learned this, no? Last day.
Yeah.
So because red bits, 8 red bits, 8 green bits, 8 blue bits, altogether 24 bits. 24 bits means 3 bytes. So this, then the value of this will be 36,
36 million.
36, yes, 36 million, million bytes, not megabytes, right? 36
Yeah.
million, so bytes. Roughly 36 megabytes, but not, it's not 36 million bytes is not equal to 36 megabytes. Why? Why? What's the reason? 36 million bytes is not equal to 36 megabytes.
Uh,
It is 1024, no? 1024
right.
bytes will form 1 kilobyte. 1024
Yeah.
kilobytes will form 1 megabyte. Understood?
Yes.
Therefore, you have to multiply 4000 into 3000 into 3. Then this is the number of bytes, 36 million bytes. Divide by 1024 will give you kilobytes. Again, divide by 1024 will give you megabytes. It is 34.32 megabytes. Understood?
Yes, sir.
It is not 36 megabytes, it is 34.33 megabytes. So let me write here. It is 36, 1, 2, 3, 4, 5, 6. I'll show the calculation same place. Divide by 1024 into 1024 megabytes. So this is the megabyte value that you get. So when you get this number, please divide it by 1024 by 1024, because that is first 1024 will make it kilobytes, then it is megabytes. Then we saw that it is equal to 34.33 megabytes. That is one image size. That is one raw image size. Okay, now what's the total size? What's the total size of this video?
34.33 MB.
Total size of video? This is one frame. This is just one frame. How many frames per
Oh,
second?
25.
Okay. Can you quickly calculate and let me know? 858. This is the size, 858.25.
No, 858.25.
8525.
858.25. 858.25.
858.25 megabytes
Yes.
per 1 second.
With the 25 FPS.
Yeah, 25 FPS. Let's calculate it. So means so this into 25. This is per second. Per second size is this one, 858. Per second
Mm.
size is this one. But how many seconds?
Oh,
You have 60 such seconds.
60.
60 such seconds.
Yeah.
So all together, so the file size will be, so this value, uh, yeah,
5149.
video size will be equal to 34.33 into 25 frames per second into 60 such seconds, and that will be, the value will be 34.33 into 25 into 60 is equal to, this is the value.
Right. Right.
Hello.
Yes, sir.
Hello. Yeah. Let me copy the value and paste it. And this is the size in megabytes. And this is equal to, so let's divide by 1024. This is equal to 50.2 GB. Please write down. Okay, now you can see right, if you record this way, so 1 minute video will be 50.2 GB if you record from 12 megapixel camera. So you can imagine the result. If you are going to record this kind of video, and if you are going to record a movie, let's say 60-minute movie, what will happen? If it is 60-minute movie or 100-minute movie, file size will be 100 into 50, which means 5000 gigabyte, which is roughly equal to 4 terabytes. One movie, 4
Oh,
terabytes. Can you save it in your hard disk?
no.
No. So that is the main reason for compression. Right? This cannot be done.
Right.
So this cannot be done because if you record this in raw way, this can be done. Yes, in production, this can be done. Production plans. So for an example, just go and search. Let's go to Google. Uh, right. Let's search for. Um, right. Let's search for original movie size. Original movie size avatar. So you can see. Okay. You can see it's what is the storage of movie size? Can you read this?
Oh, 1 million gigabytes.
Yeah, it's 1 million gigabytes. 1 million gigabytes means you just divide by 1000, so it's 1000 terabytes, right? So they do
Oh,
this in
yeah.
they do this in production plants, but 1000 terabyte movies, who is going to download that movie? Who's going to watch that movie? So if you can watch that much quality movie, yes, it's really great. But the thing is, unfortunately, we
Mm-hmm.
can't keep those movies in our hard disks. We cannot transfer those movies. Therefore, it is required to have compression. It's required to have compression algorithm to reduce the size of movie. There are different compression formats. For an example, for picture also. So this, I think you have heard of JPEG. JPEG is a compression. So it is. So we think that JPEG is a picture type, but it is not. It's a compression type,
Oh,
right? It's not file type. It's a compression type because in maybe in our junior ages, in your O levels or some other level, you have learned that this is a file type. Yes, that's true. It's a file type, but basically it comes through this compression algorithm. So actually, you don't have this much of details when it comes to compression. You don't have this much of details. So, but in your maybe when you're learning for your degrees or image processing related anything, so then you can learn this stuff. So basically, image will be blocked or splitted. So then there's something called district cosine transformation, quantization. Then likewise, you have various algorithms to compress. So let me tell one thing. So when what's happening when you are compressing, let me show by example. Let me show by an example. An image in my screen. No? Can you
yes.
see? Hello.
Yes, sir.
Right. Okay. So the file size of this image. So the file size of this image, let's, what I can do is, one thing I can reduce the image size. One thing I can reduce the image size. So you can see it is 5266 into 311 pixels, and resolution is 300 pixels per inch. But when you reduce the pixel size, so it is always, it will decrease the quality. So let me go to
Right.
image size, and here, so let me see in inches. It is 17 by 11 inches. And let me reduce the number of pixels per inch. Let me reduce this to 10 pixels per inch. Keep in same 17 inch and 11, 17 by 11 proportion. ලාමත් size එක
Okay.
එකමයි. 17 11 කරලා මම මේව කරනවා, size කරනවා, resize කරනවා. So this is not compression basically. So bind this is what will happen. You can see now image is blurred out. You can see the pixels.
Yeah. Yeah.
So that is not actually the compression. That is called resizing. So resizing is one method that you can do, or you can reduce the number of pixels, and that is one way of reducing the image size or video size. But that is not good, no? That is not
Yeah.
good because that will reduce the quality. So let me keep the same quality. But what you can do is, for an example, these areas, you can see these areas white color. This waterfall pixels are basically, those are white color. Here, these are white color pixels. So you can just,
Yeah.
so in these compression algorithms, the special thing is, so there are small, so okay, let me zoom. Okay, can you see the pixels?
Yeah.
Okay, so here also you can see, so can you see there's a small difference here? White color and some light color is there. Here this is white and this is some light color. Can you see the
Yeah.
difference here? Right? Can you see?
Yeah.
So
Yeah.
these kind of things can be ignored. For an example, so this same, so I'm going to, yes, I'm going to recolor. I'm going to use the brush, and I'll use this color and color this area. Same color, same color. Likewise, I'm going to convert this to one color pixel. So there are multiple colors now, but that will not be visible in the image when you see the overall look. So now you can see the overall look. But in this overall look, so whatever you have changed, you can't see. So this is the kind of algorithm used in lossy compression. Okay, lossy compression එකේදී කරන්නේ දැන් මේ minor changes තියෙනවා අපේ ඇහැට පේන්නේ නැති තරම් මේව පේනොනට මේ එහෙම ලොකු දෙයක් නෑ මෙතන මේ මෙතන දැන් මෙහෙම පික්සල් ගොඩකින් පෙන්නන්නේ අපි පික්සල් ගාන අඩු කරනවා කලර් ගාන. හැබැයි මේ ඇහැට පේන්නේ නැති අපි කියන මේ so these
Right.
pixels our eye will not recognize these pixels basically. We can do that some kind of things for those pixels because human eye will not recognize those changes. So that is one thing that is but destructive. Destructive means you are removing those pixels. ඕක වෙන්නේ සමහරවිට අර අහසේම ගොඩාක් ලයිට් තියෙද්දි ඔයගොල්ලෝ බැක් මේ ෆොටෝ එකක් ගන්නවා මිනිස්සෙක්ව ලයිට් කරලා. Here I have used flash and maybe lights to get this image because this area is very lighter. So, but normally when you take a
Mm-hmm.
picture against light, what will happen? This area will wash out, no? All the pixels,
Yeah.
even sky is blue in your photo, what will happen? All the pixels you can see in white color. All the pixels you can see in white color in the image, but you can see the person perfectly. In the other hand, this can be
Mm.
done for dark pixels. In the other hand, this can be done for dark pixels. For an example, these are black color pixels. Again, it's not our concern. So there can be minor changes here, minor pixel changes. These minor, so you can see multiple colors are there, but multiple dark colors. You can make all these dark colors, all these multiple dark colors. Let's select one dark color, and you can apply all these dark colors a single dark color. Okay, you will not notice the difference. The advantage is you will not notice the difference. Okay, light color areas you can simply wash out to a single color.
Yeah.
Dark color areas also You can make. But when you have the other colors, it's quite difficult. So basically, you have to take relatively, you have to change other color pixels. But you can't do this much. If you do this heavily, what will happen? Again, there will be something called visual artifacts. Have you heard this term, visual artifacts? Visual
No.
artifacts. Visual artifacts means, so when you're getting pictures, photography, let's say, let's refer to the photography. So visual artifacts means you cannot, it's not shown properly. So anyway, you can see with that it has changed. Likewise, you can see some color difference in your using your eye. Right? This is one thing. So this is one, but this is happened due to dust and all. No, this is happening due to dust, dust or pollen. No, so
Yeah.
this is not purposely taken out. No, but when you reduce the quality, when you reduce the quality of the image, so it can be lead into this kind of things, but not exactly the same. But you can see that this image is like kind of not really good in quality. Likewise, but you have to reduce the size, keeping that in mind. Okay, let's go. And I'm going to save this image, same image. I'm going to save this as, I'll use a folder. Maybe I'm going to use my desktop. Here, Ansinan, let's say as d1.jpg. This is with 12 quality, right? 12 jpg. Save. So let me reduce the quality again. File, save as, here d2, let's say d2. D2, I'm going to save this as with 8 or high quality. So let's save this, save again as D3. D3, I'm going to save this as low quality or 4. But this will not change the pixel number of pixels, right? Image size. I'm not going to compromise the image size or number of pixels. I'm going to use the algorithm in JPEG. But JPEG is what? JPEG is lossy or lossless? JPEG is, hello? Hello, can you hear me? Siddhas? Hello?
Hello, sir. What did you say? Sir, can you hear me?
Yeah, JPEG, is it lossy or lossless? JPEG, JPEG.
Hello?
This JPEG, is it lossy or lossless? So let's save this in D4 as well. I'm going to save this with 2 pixels quality as 2. Okay, let me close this one. Same image, I have saved this in different qualities. Same image I have saved in different qualities. Now you can see, so image size, the first one is 19, second one 3.6, third one 1.6, and likewise the last one is 1 MB. Hello. So these are the
Yes, sir.
image sizes. So 4 images, same image, 4 sizes. Let me open and show you. Let me open and show you. So So this is the first image, and this is the second image. First image, second image, third image, fourth image, but you will not experience much difference. First image, let me zoom and show this. This is first image, second image, third image, first, second, third, fourth. Can you see any difference?
No, not a big difference.
No big difference. No? So no big difference. This is due to property in our eye. So let's show you. Okay. Can you see the sky in first and last image? Can you see the sky in first and last image? Is there any difference? First image and last image sky. Is there any difference?
No.
Okay, I think you're getting with reduced quality. Is that so? Okay, what I'm going to do is let me pause this for a moment. I shared you this image, the sky in the first
Hello.
image and sky in the second image. Is there any difference? Can you open and see? If you continue to reduce the quality, one time there will be these kind of visual artifacts or changes appear in your image, but not always. In some sections, if you continue to change, because it's going to represent the area in same color by reducing number of colors, then we can see the gradient is not really here. The other areas it's okay, but here this area, especially when it comes to sky, you can see. So these are called visual artifacts of the areas where the quality is compromised. But number of pixels still the same, image size reduced, but with reducing image size, the quality of the image will be also reduced. So this is the result of lossy compression. But you can make like 30 megabyte image even less than 1 megabyte using this method in lossy compression. In lossless, other hand, lossless is kind of advantage, mostly used for representing illustrations. And vectors basically they use algorithm based thing. So those are the rasters are pixel based. Still for pixels, so we can use lossless compression. But lossless compression, so you can't reduce the size as much as this lossy compression. Lossy compression is very easy to reduce the size. But lossless compression is quite difficult to reduce the size, but it will reduce the size while keeping the quality. You can regenerate the previous information. That is the idea. You can regenerate the previous information in lossless compression, but in lossy compression, you cannot regenerate the previous content. Understood?
Yes, sir.
Right. And this is about that and video representing, and then about the lossy compression and lossless compression. So with this part, right? So they have given JPEG, GIF, PNG, TIFF, right? So different with these different file types follow different compression styles. So for an example, JPEG, GIF is quite low quality, but very small file size. PNG quality and TIFF quality are high. PNG quality is also high. TIFF quality is also high, but JPG is average. GIF It's mostly GIFs are with reduced quality, reduced image quality, right? So those are the things that we have to learn under this chapter. With that, actually, we will be finishing this. Next, we have to move to the next chapter, or the communication and internet technologies. So I'm going to move to that one. So is there any questions that you have related to the previous chapter? Do you have any questions to discuss?
Mhm.
Or can we move to the
Let's
next one?
see. Uh,
Yes. Can you move to
um,
the next one? Or
so could you explain the sampling once again?
sorry,
Could you explain sampling once again?
sampling, right? And quantization. So related
Yep.
to, yeah, related to audio.
Sound.
Yeah. And sampling basically what's happening. So here you have analog wave or regular wave. Sampling, what you are going to do is you divide this wave to equal time periods. So assume, okay, assume the sound, this is 1 second period. This is 1 second wave. This wave is 1 second. And you are dividing it to eight pieces means 1 divided by 8 seconds. So t equal 1 divided by 8. T equal 1 divided by 8 seconds. Likewise, this is 2t again, 1 divided by 8 plus 1 divided by 8. Likewise, you divide this to equal time periods. So that is called sampling. So why you divide this to sampling? Because in equal time period, you can take the average value. The average value you have to take, you can take and represent it in. So the other hand, you have quantization levels. Quantization levels means, so the value when the time is t, what is the value of this wave? When time is t, average value is 101. When time is 2 t, the middle value is 001. When average time is 3t, the middle value is 001 or 010.
Right.
Likewise, it uses the sample. Sampling means how many equal period that you are going to divide. When you increase the sampling rate, what will happen? When you increase the sampling rate, what will happen? It will increase the quality of sound because you are going to take more samples. Then you can, here, for an example, here this wave, see that in t time, this touches 10. So this actually touches 110, yeah, 110, and it touches 101. It also touches 100. It also touches 1011, and it also touches 010. All three levels it passes within t time. T කියන කාලෙදී within t time it passes, it crosses 101, sorry, 110, 101, 100, 011, 010. It crosses all these points. It crosses all these points. But you capture only one point, no? Yeah, you captured only
Yes.
101. Why? Because your sampling is common for all these values. But if you increase the sample rate, for an example, let me increase the sample rate. I'm going to split this and, okay, not this one, not only this one, I'm going to split this, just merge it, and then I'm going to split this 8, 9, 10, and we are going to split this to 5. Okay, now you can see. So if you increase this to more levels, if you increase this to more levels, what will happen? Now you have more levels. Now you can see this time, this interval it touched this value only. This interval, the second interval, it touched this value only. Third interval, third interval, it touched another value. Fourth interval, another value. Fifth, separate value. Sixth, separate. You can get all these values. You will get 100, then 101, 100, then 011, 010, as well as this is 010. So here 011, you will get all the values. Understood? When you increase the sample size, so you can capture more values and you can represent signal more accurately. Understood?
Yes.
Right. So is there any other things that you want to ask other than this?
Uh,
We discussed sampling, quantization, image representation, character representation, colors, videos, and finally about the lossless and lossy compression. That is our chapter number 1.
okay. That's all, sir.
Okay. Then chapter number 2, under this actually we have to mark what are the areas that we have discussed. We have discussed few areas. For an example, we discuss about the medium, transmission medium. Can you remember the transmission mediums we discussed? There are three mediums, three wired technologies. Can you remember the technologies?
Yes.
Wired transmission, there are three technologies: coaxial cable, fiber optics, and twisted pair. Can you remember? Or cannot? Hello? Right. In case if there's a huge delay, please let me know, then we can postpone, right? Okay. I think now it's quite
Okay.
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 Right. So then we discuss about
Yeah.
three kind of transmission media. We discuss about three kind of wired transmission media. Three kinds of wired transmission media. Can you remember? Can you remember them?
Yes.
So what are they?
There's the type of wires, sir.
Yeah, type of wires.
There's the coaxial cable, and
Mm.
then there's the twisted pair cable,
Uh-huh. And fiber optics.
and then the
Optic.
fiber optic.
Yeah, fiber optic. Which is faster?
The fiber optic.
Yeah, fiber is always fast. Okay, so these are the three we discussed. So twisted pair, coaxial, and fiber optics, and these are the characteristics basically. When it comes to cost, twisted pair has the lowest cost, whereas the fiber optics the highest. And when think about the interference, twisted pair is it is getting affected. It has more interference, and but fiber optics, the other hand, it has the least because it's using light, and then so actually distance they have not given, but distant pair and coaxial cable maximum go up to 100 200 meters, and but the fiber optics it can go up to, it can send data even kilometers, right? Therefore, fiber is most reliable thing, but thing is the cost of fiber optic is high. It's very, very high. Okay, then the images of these things we discussed. This is what is this shielded twisted pair or unshielded twisted pair? Shielded or unshielded? There are two kind of twisted pair cables. One is shielded, the second one is unshielded. So what can you see in this image? Is it shielded or unshielded?
It's unshielded.
Yeah, it's unshielded. So in shielded twisted pair, you have shields or covers. To each pair, you have separate covers. So sometimes students will misunderstand just by seeing this image. They might think that since there's a cover, this is shielded, but that is not. In shielded twisted pair, you have cover for each two Each pair you have different count. So this is unshielded. This is even more cheaper than shielded tested pair. But again, the interference is very high. The interference is very high. But normally, since this is the cheapest, we are using this in network transmission. Even interference is very high, we are using that. Why? Because we know that nowadays hardware components are very fast. In case of data damage or loss, it can resend easily. Therefore, we are not going to compromise. Uh, so we are not going to compromise, or we don't want to use fiber optic to transmit shorter distance data, because it is always possible to transmit data for shorter distance without much cost, without any cost actually. Because in local area network, LANs, you can retransmit data easily, even if you not received. Retransmitting will not cost, because you are not using ISP in local area network. No? Local area network is belong to you, no? That is your infrastructure. Wage lab ekana, if it is your school lab, if it is your school, your own building, it's your own infrastructure. So that will not cost to you. But in case of internet, in case if you're using internet, you have to use more reliable service. Otherwise, we will face difficulties. For an example, now also, especially when it is rain, getting affected. So to stop that, actually, we need reliable service. That's why in internet, fiber optics, mostly fiber optic is the number one solution when it comes to the internet. But this copper wires are quite less reliable, and then WiMAX, the wireless services, even less reliable. Because wireless services always getting affected with the climate, clouds, with obstacles, it's getting affected. Okay, right,
Okay.
right. So basically, so this is coaxial. We discussed this, and then fiber optics. This image fiber optics, the third one, it uses light. The problem with fiber optic is the cost basically, and it is not possible to bend this. Frequently bending the wire is difficult. You can't bend the wire frequently because it's fiber and you are sending light. Okay,
Right.
right. Then we discuss about wireless technologies, and let's discuss this part next day. So wireless technologies and what are the other methods of transmission. And actually, this chapter is quite long, but we have discussed.
Right.
I'll go according to your book order and discuss things in next day.
Yeah.
Okay, and thank you very much.
Okay, sir.
Okay, see you next
Okay,
day.
thank you, sir. Good night.
Good night. Bye.